Welcome back to Euclidean Geometry Grade 10. Let's begin. Given the writer BCDE is a parallelogram. BCDE is given as a parallelogram. And AODE is also another parallelogram in the very same writer. We're having now two parallelograms. So the question now, it says, prove that OF is parallel to AB. Let me give a highlight. To OF, prove that this OF is parallel to OAB. How can these two lines be in parallel to each other? So if you want to give a try, you can pause the video. Otherwise, here is the solution. We know that in a parallelogram, having some diagonals in a parallelogram, they bisect each other. That's what makes O being the midpoint of BD. So O is the midpoint of BD in the biggest parallelogram. Then in the smallest parallelogram, we also have F being the midpoint of AD. AD is the diagonal of the smallest parallelogram. So we're having O and F being the midpoint of these two sides of a triangle that we can draw this way, of a triangle that we can draw. This is a triangle that we have now. To make things clear, now you can see that this tells us that we are having BO is equal to OD, because O is the midpoint of BD anyway. Then AF, we're having AF is equal to FD, because F is the midpoint of what? Of that diagonal AD. So on that note, you can see that this takes us to midpoint theorem, because the midpoint theorem says if the line is drawn from the midpoint of two sides of a triangle, it has to be parallel to the third side of a triangle. So that is why this OF has to be parallel to AB. So how do you then present that? We are having OB being equal to OD, reason diagonals of a parallelogram, diagonals of parallelogram. We know that diagonals of a parallelogram, they bisect each other. You may not specify that what do they do, just say diagonals of a parallelogram. Then also OD, OF, no, not OF, but AF is equal to FD. So hence you have seen that this F is the midpoint of this diagonal AD. So which means these are diagonal of parallelogram. So the diagonal of parallelogram, we know that the diagonals, they bisect each other. So having that, then therefore what you have, OF is going to be parallel to OBA. What is the reason for that? This is the midpoint theorem. This is the midpoint theorem. This is the midpoint theorem. So we have proven that these two lines are parallel to each other. Once this happens, it's always the case that the line that bisects two triangles of a triangle, two sides of a triangle, it has to be parallel to the third side of a triangle. So that's what midpoint theorem tells us. Then moving to 9.2, prove that ABOE is a parallelogram. ABOE. Let me wrap all these other things. We have ABOE. We are to prove that this is also what? A parallelogram. as well. So the idea is that we have already proven that this side is parallel to this one. So we really don't have to lose that information. We know that this side is parallel to that side. And of course, we know that it was given from the beginning that this is a parallelogram. This is a parallelogram. So if this is a parallelogram, which means this side has been parallel to this side from the beginning. So if that is the case, this side continues to this y. This makes this one also be parallel to EA. So UBO in this new parallelogram that you are proving is parallel to UAE, because we did prove that if OD is parallel to UAE, then OB is also parallel to UAE, because this is just the eccentric line. Now, how do you then present that? The idea is once the two pairs of opposite sides in a quadrilaterals are parallel, that quadrilaterals become a parallelogram. Once there are two pairs, let's say we are having this one, once this side being parallel to this one and this one being parallel to the other one, then therefore this quadrilateral just become a parallelogram because of that. So that's one theorem that we need to note about parallelogram. So the fact that this side is parallel to this one and this one is parallel to this one, then therefore these two quadrilateral is now a parallelogram. Now we know that AB, for the presentation now, AB is parallel to OF. Reason, we did prove that. Then we know that OD is parallel to EA from the beginning, from the original parallelogram that was given. So the reason for that, opposite side of parallelogram. The opposite sides of a parallelogram, they have to be parallel to each other. Then therefore OBO is also parallel to AE. And so that is just the finishing reason for the statement above. Then therefore we are having A B O E being what? Being a parallelogram. Is a parallelogram. Reason, because opposites pairs, two pairs of opposite sides are parallel. So you can just write parallel to this one. So if two pairs of opposite sides are parallel in a quadrilateral, that quadrilateral becomes a parallelogram. So that is what we have. So let's come to 9.3. 9.3 is prove that AOB is congruent to EOD. Let me just give a highlight. Let me just give the highlight. AOB is congruent to EOD. So we are having that one. So we have to prove that AOB, this one, is congruent to this one. So we have these two triangles now. We have to prove that they are congruent to each other. So the idea is, let me just rub everything else. Let me just we're having these two triangles, especially we have already noted them up. So AOB, which means this angle, what are we having? We have this triangle, and this triangle. Are they parallel? Are they congruent to each other? We just need to prove that. So what are we having? We have this side is equal to this side. Just from the beginning, this side is found in this other triangle, this other side is found on the other triangle. Let me just write this one, because we're having AO is equal to DE. The reason is that these are the opposite sides of a parallelogram. Opposite sides of a parallelogram. So we also have ODBO is also equal to OD. So BO is also equal to OD. What's the reason for that? Because these are diagonals of parallelogram. So these are diagonals of parallelogram. We know that they bisect each other, which means that that's what makes this piece being equal to this other piece. Now moving forward, we are having this other side now in the other triangle and in this triangle. You can see that these sides are equal to each other, because we have proven that ABOE is a parallelogram. So if it's a parallelogram, then therefore the opposite sides has to be equal to each other. That's what makes AB being equal to OE. Reason: opposite sides of parallelogram are equal. So this is what we have. So we have proven that now. Therefore, triangle ABO is congruent to triangle EOD. What's the reason for that? We have proved all corresponding sides being equal to each other. So this is what we have. So the diagrams of this nature, they really do confuse, especially when you are having a lot of parallelograms to take note of. But the idea is to make some useful consideration and be very vigilant when you are looking for the other things, so that you don't get confused when you are looking at these parallelograms and you are being confused by other lines. Just be strict and get things be done the way they are there. So it is wise to highlight what you are talking about at that moment, so that you don't get confused and don't confuse some other things. So having that being said, see you in the next video.